Hello everyone, this is Khadiza from Sylhet, Bangladesh. I will present our work at this prestigious conference on behalf of my team, Moulia Proma, Bushra Siddika Priya, MD Jamaner Rahman, and our corresponding author, MD Saidur Rahman Kohinoor. Before I begin, let me express my sincere gratitude to the organizer and all the dignitaries to exhibit our work at the 2023 First International Conference on Advanced Engineering and Technologies. For us, it's an absolute honor. The title of our work is Assessing the Robustness of Machine Learning Algorithm for Cardiovascular Disease Detection Across Diverse Clinical Datasets. Here is our presentation outline. Now I will commence my presentation with a brief introduction of our chosen topic as well as I will express the objective behind our study. The human heart, a vital organ, serves as the lifeline of our existence. It's however vulnerable to certain risk factors such as high blood pressure, high cholesterol, diabetes, and obesity, which significantly contribute to the prevalence of cardiovascular disease. According to World Heart Foundation, cardiovascular diseases account for approximately 60% of deaths globally, and here in Bangladesh, they make up 30% of our nation's mortality. This is where machine learning enters the scene, offers transformative solution in the field of healthcare, promising improved diagnostic accuracy and early intervention. Our research has specific objective. We aim to assess the robustness of machine learning algorithms for cardiovascular disease detection across diverse clinical datasets. This involves evaluating the performance among models we selected such as logistic regression, decision tree, random forest, gradient boosting, naive Bayes, k-nearest neighbor, support vector machine, multi-layer perceptron, and extreme gradient boosting, and identifying the most reliable one. In order to construct a prediction system for detecting cardiovascular disease, which of the nine machine learning algorithms we choose is more reliable when we apply to various datasets? This question lies at the core of our research, and we will explore it in depth throughout our presentation. The objective of our papers are to assess the accuracy and effectiveness of multiple machine learning algorithms across diverse datasets, identifying the best performing algorithm among several models, and ultimately develop a reliable system for cardiovascular disease risk prediction. Now moving to the existing work to our study, we have extensively reviewed over 40 papers in the field. Among these, the study by H. Jindal, he used three classifiers such as logistic regression, random forest, and k-nearest neighbor were employed to predict heart disease using the heart disease dataset from UCI repository. Their research they achieved highest 88.52% accuracy using KNN algorithm. The work of MJ and Naim introduced a heart disease prediction system employing k-nearest neighbor, random forest, and naive Bayes model. Notably, they achieved an impressive accuracy rate of 95.63% using the random forest classifier, demonstrating its efficacy in disease prediction. Additionally, V. Rajalakshmi proposed their own heart disease system, which showcased the application of k-nearest neighbor model. Their research yielded an accuracy of 85.71%, further highlighting the potential of KNN model in heart disease prediction. These studies collectively contribute to the body of knowledge in cardiovascular disease prediction and inform our research in selected appropriate machine learning models for our study. This is the workflow diagram of our study. Firstly, we collected two different datasets from Kaggle, which are the heart attack dataset and the public health dataset. Both of the datasets contain 14 attributes. The heart attack dataset contained 303 instances and the public health dataset contained 1025 instances. In the pre-processing stage, we conducted a thorough check for null values within the dataset to ensure the integrity and completeness. Subsequently, we divided the dataset into two subsets, allocating 90% for training and 10% for testing. According to our observation, this ratio is rather effective in terms of our dataset dimensionalities. We used grid search CB to find the best parameter for hyperparameter tuning for each model. We used these 9 machine learning algorithms, which are logistic regression, random forest, naive Bayes, decision tree, gradient boosting, support vector machine, multi-layer perceptron, extreme gradient boosting, and k-nearest neighbor. In evaluation process, we assess and compare the 9 models mentioned earlier, considering performance matrices such as accuracy, precision, recall, and F1 score. Here is an overall performance table of all machine learning models. From the table, it can be seen that our proposed model, surprisingly random forest and multi-layer perceptron, performs the highest overall accuracy on both datasets, 95.14% on public health dataset and 93.54 on the heart attack dataset. Precision, recall, and F1 score are also expressive, and conversely, the gradient boosting shows relatively low performance with 77.41% accuracy on heart attack dataset, which is the least amount of accuracy compared among all other models. The second nearest identification was received approximately 90% accuracy by logistic regression, decision tree, support vector machine, and k-nearest neighbor models on one of the dataset. The k-nearest neighbor and support vector machine performs well on the public health dataset but not on the heart attack dataset. The naive Bayes had poor performance on both datasets. On the other hand, extreme gradient boosting expressive accuracy on the public health dataset is 95.14%, while it performs poorly on the other dataset with 87.09% accuracy. According to the given table, random forest and multi-layer perceptron provided relatively similar results in evaluation matrices for prediction of cardiovascular disease in heart attack dataset and public health dataset. Both these models gave the highest accuracy value in the precision, recall, and F1 score. And here the comparison chart for the performance matrices of the 9 models, the accuracy and precision, recall, and F1 score comparisons. Now moving to our future plan. We aim to enhance our research by increasing the dataset size. Already we are collaborating with two medical sectors for primary data. We will deploy our selected models in user-friendly web and mobile application utilizing our real dataset and using our selected machine learning model. We also try to incorporate deep learning models based on our real dataset to improve accuracy. To sum up, our research employed 9 machine learning techniques to achieve the highest accuracy with the multi-layer perceptron and random forest algorithm, standing out by achieving an impressive accuracy rate of 95.14%. Additionally, XGBoost demonstrated strong performance in one of the datasets. These findings underscore the potential of machine learning in cardiovascular disease prediction and open doors for further research and practical application in healthcare. These are the references that we used in our study. Now I would like to open the floor for questions and invite the session chair and audience to share their thoughts and inquiries regarding our presentation. I am truly thankful for the opportunity to share our research. Thank you.